Hello class, welcome to today's lesson. Today is going to be a very important day for us in the sense that we're going to try to solve this problem, okay? The problem for today, which is the following. Find the slope of the tangent line to the function f of x equals x squared at points 1, comma 1 and 2, comma 4. So at two different points. And here I'm showing you the function. I'm not showing you the left side because it's not important at this point. I'm showing you points 1 comma 1, 2 comma 4, and I'm showing you the tangent line. Okay, this is the tangent line to the graph of this function at point 1 comma 1. And the problem is to find the slope of this tangent line. Remember, this is different than secant line. Secant line, if you remember from the last class, a secant line was something like this, okay, which cuts the graph of a function at a minimum of 2 points. This is a secant line. Well, I'm gonna draw it in yellow. This is a secant line. This is your tangent line, okay, línea tangente. Okay, why do I say that this is an important day? Like, am I exaggerating or what? Okay, no, I'm not. I'm not exaggerating. This problem, guys, this specific problem, I mean, this is a specific case of the more general problem, okay? I could have used any other function or any other 2 points. But the basic idea behind this problem is, like I said in the first day of class, this is what gave birth to the field or the branch of calculus, which is what we are studying, okay? Calculus. This simple innocent problem. And even though it looks very simple and very, I don't know, silly or unimportant or whatever, believe me, by solving this problem in the more general form, we're going to discover something called the derivative, okay, a very important mathematical object, the derivative. And basically, with this in our hands, we have discovered so many things in science and engineering, okay? Every single technology advancement that has been produced in the last 200 years, the steam engine, the computers, the flight to the moon, every single thing of those, okay, has been produced in a very large part due to this concept and its causing concept, which is the integral. Okay, these two concepts are the most important concepts in calculus. These are the central concepts in calculus. And I repeat, by solving this problem, this very innocent problem, we're gonna understand what the derivative is. And trust me, it is a very, very important problem. Okay, and just a word of warning. The ideas that are going to be expressed in this video may be a little difficult to understand because I'm going to do the analysis in variables. Like, I'm not going to work in any specific example in a moment. You're going to see what I mean by that in a moment. And you may need to see this video maybe a couple of times or 3 times or maybe 4 times to really understand and grasp what I'm going to be telling you. Okay, so this is the problem for today. I want you to focus on solving this problem only. Okay, let's start. I'm gonna close this for a moment and let's go to this little thing here. Okay, I want you to pay attention to these guys. What do we have here? We have our function, our quadratic function, f of x equals x squared. It's our parabola. Okay, there it is. Good. Now, I'm gonna identify or locate my point, 1, 1, my point of interest. And I'm gonna draw the tangent line to this function at this precise point. Perfect. What is, again, remember, what is the problem for today? Finding the slope of this tangent to this function at this precise point. Why do I say that at this precise point? Well, because this point can vary, okay? For example, if I do this, look, I can change it. Look at this, okay? You see? For example, another problem would have been find the slope of the tangent to the graph of f of x equals x squared at the point 2, 4. You know, it's almost 2 and it's almost 4. Or find the slope of the tangent at point, let me get close there, at point minus 3, 9, you see, and you're going to get a different slope, okay? For all of these different points, obviously you get different inclinations of the tangent line, so they are different problems. I chose 1, 1 for simplicity. Let me put it right there again. Okay, there it is. And so we're gonna keep this point because it's a very simple point. Okay, so that's the problem for today. How are we going to solve this problem? This very essential and important problem in mathematics. We're gonna use the two concepts that we have talked about in the classes before, which is number one, the concept of limit, and number two, the concept of the slope of a second line to a function between 2 points, which is precisely this. Look, I'm gonna erase the tangent line for a moment. There it is. This blue line is a second line. This is a second line to the graph of this function x squared. At what points? At point P1, which is 1, 1, and P2, which is let me move it a little bit because I want it exactly at 3, 9 because of simplicity. Okay, at point 3, 9. Okay, so again, this blue line is the second line to this function, to the graph of this function, and that cuts it at points 1, 1 and 3, 9. Okay, question, guys, and it's a rhetorical question. Okay, you cannot answer. Can you find the slope of this second line? Have we done that the class before? This second line goes through these 2 points. Can you find the slope? You should, right? Because we already answered some of these exercises. All we have to do is look at these 2 points and just follow the formula for the slope between 2 points. Okay, for the slope of the line that goes through 2 points, and that's it, right? We can do this. It's extremely simple. Extremely simple. I want you to stop the video very quickly. Stop the video and then calculate the slope of this second line. What you should get is 2. No, 4. I'm sorry. 9, 8. Yeah, it's 4. I'm sorry. You should get 4. Okay, perfect. So let's continue. So basically, we know how to calculate the slope of this second line. Okay, how does that help me solve my original problem, which is this, getting the slope of this tangent at this point? Okay, in the following very, very clever way. Look, we're gonna do the following. I'm gonna show both lines. The blue line is the second, the red line is the tangent, and I'm gonna do the following. If you notice, well, first of all, let me make a comment. If you notice, we cannot calculate yet the slope of this tangent because all we have about this tangent is that it goes through 1 point, 1, 1. You see? And you cannot calculate the slope of a line if you only know one of the points through which they go. Okay? You need at least 2 points. So far it seems like the problem is unsolvable. But here's when it comes the second line to the rescue, so to speak. Okay, so let's see how this works. Pay a lot of attention, guys. Okay, what I'm gonna do is this. I'm gonna do a process of a limit. And if you remember, a limit, what it means is basically making something approach something else. Okay, in this case, what we're trying to do is making the second line, this second blue line, approach the tangent line. You see, as I move this point 2 in this way, the second line is approaching the tangent line. It's sort of becoming the tangent line. Can you see? As I do this more and more and more and more and more, the second line gets closer and closer and closer to the tangent line. And at some point, they're going to be the same. Look, right there. They coincide. You see? There it is. And how does this help me solve the problem, the initial problem, the original problem? Because of this, guys, all you need to do is the following. Remember, we were in 3,9, approximately over there. That's fine. All you need to do is this. It's a very simple process. All you need to do is approach the second line to the tangent line and calculate the slope of the second line. For example, can you calculate the slope of this second line right now? Yes. We don't know how much it is. Okay, we said it was 4. But what about this other point? Can you calculate the slope of this second line? Yes, yes you can, because you have 2 points. How much is it? We don't care. So at this point, we don't care. It's just a number. We can calculate it. Now, can you still calculate the slope of this second line? Yes, you can, because you have 2 points, P1 and P2. And you calculate it, and that's it. Can you calculate it now? The slope? Yes, you can. You have P1 and P2, and you just follow the formula. And let's do that over and over and over again, and closer to P1. And at some point, the slope of the second line will be so close I don't know what happened. At some point, it will be so close to the slope of the tangent line that for all practical purposes, we can say that they are the same slopes. Okay? When the second line reaches the tangent line, then both slopes are the same. You see? And therefore we have been calculated the slope of the tangent line. You see how it works? So basically we are approaching the second line, which is this, as a limit towards the red tangent line, and at that point both coincide, and therefore we have calculated the slope of the tangent line. Okay, now that is the basic idea. Just make the second line approach the tangent line, and as we do so, the slope gets closer and closer to the slope of the tangent. That's the basic idea. Okay, now how does it work in real life? And now that you have an intuition about this, how can we really calculate our problem? How can we really solve it? Okay, here comes the very difficult part, in my opinion. At least this was difficult to me at your age. So let's start. First, I'm gonna draw my Cartesian plane. This is the axis for the values of the function. This is the axis for the values of the x variable. And remember, we are dealing with the quadratic function. Okay, so it's f of x equals x squared, and it goes more or less like this. Let me redo it. Okay, that's good. Okay, and let's suppose that my point 1, 1 is right here. Okay. Okay, so how do I calculate the slope of the tangent line at this point? Okay, what we do, guys, is the following. We're gonna resort to an analytical approach. Analytical approach. Whenever you see this word in mathematics or this phrase, analytical approach, it means to do a general approach, a general method in order to solve the problem. Basically, what we want is just get the slope of the tangent line at that precise point, which is 1, comma 1. But how about solving the problem in the most general case? In the most general case, what do I mean by that? Well, what I mean is this. How about solving the problem for this point, which I'm gonna represent in variable form, okay? What I mean by this, I mean this. The coordinates of this point are gonna be the points or the numbers A, okay? This marking here is A, so the x coordinate of this point is A, and the y coordinate of that point clearly will be f of A, right? Because remember that these are the values of the function. So we have this point, and I want to calculate the slope of the tangent that goes through this point, okay? Through this point, A comma f of A. Why so? Why not go directly to 1 comma 1? Because in mathematics, in many cases, you cannot solve a specific problem unless you have solved the analytical general problem. Okay, that's hard to understand at this point for you, but that's how it works. Okay, we need to solve the most general case. Okay, so how do we do it? By resorting to our second, 1 second. So I'm gonna place another point right here. Okay, and what are the coordinates of this point? This one, this is x, and this one, which is y. And I'm gonna do another little trick. Look, I'm gonna tell you, I'm gonna define this little part in here from this to this point, or from this number to this number. I'm gonna represent this part with the letter h, okay? And I'm gonna call it the increment. H is known as the increment. You're gonna know why in a moment. So from here to here, that's equal to h. So if this particular number is a, and the section or the part from here to here is h, okay, the length of this section or segment is h, then what is this number? This new number. If this is a and we are adding h, this part, then this number is clearly a plus h. This particular number here, this is a plus h. This is a, and then a plus h gives me a plus h. You see? All of this looks very weird at the beginning, but you're going to understand what I'm doing this in a moment. Okay, and so what is the y coordinate corresponding to this point according to the function? In the same way as a and f of a, then if this is a plus h, then this number should be f of a plus h, this number. Okay, and so basically, my coordinates, the coordinates of this point are the following: a plus h, comma, f of a plus h, and the coordinates of this point, that one, are a, comma, f of a. So we have the coordinates of both points. Okay, and also let's label them. Okay, let's label them p1. This is p1. I'm gonna write right here. This is p1 and this is p2. Okay, So the coordinates of P1 are a comma f of a, and the coordinates of P2 are a plus h comma f of a plus h. Okay, all right, that is the first part, so to speak. Now what? Now let's do this. I'm gonna draw in red, and I hope it doesn't get too cluttered, the whole diagram. I'm gonna draw in red the second line that goes through those points. There you have it. This is the second line that goes through P1 and P2. Now, let's calculate, guys, the slope of such second line, this red line. Okay, I want to calculate the slope of this particular second line. Okay, let's do that. I'm gonna call it M sub S. Why? M for slope, S for second. The slope of the second line. Okay, any slope of any line, as you remember, is equal to y2 minus y1 over x2 minus x1. So if I have 2 points that go through the line, and all I need to do in order to calculate the slope is just inputting or substituting those coordinates of those 2 points in here, and I'm done. I'm gonna continue over here. Okay, now my question is this: do we have those 2 points in the second line? Yes, we have point 1, and we know the coordinates, which are this a comma f of a, and we have the point 2, and we also know the coordinates a plus h comma f of a plus h. So basically I'm just gonna substitute these coordinates in this formula. So the slope of the second line will be y2, which is this number, right? Minus y1, which is this number, over x2 minus x1. What is x2? It's this number. Plus h minus x1, which is this number. Okay, so we have this. Now what? Let me raise this thing. Now what? Okay. Uh, in the same way that we did the exercises in the last class about having f of a number and so on, we're gonna simplify this a little. So first, f of a plus h. What is your function? Your function f. Your function f is the function x squared. It is a function that when you evaluate it in a number x, you get the square of such number. So, okay, so basically in here, when I have f of a plus h, what I'm doing is nothing but evaluating the function f in this number, a plus h. Okay, in all of this number, a plus h. So basically, what we have is that such evaluation amounts to a plus h to the square. You see? Minus f of a. How much is f of a? Well, if f of x is equal to x squared, then f of a is a squared. Like so. Okay, good. Next, over this denominator, a plus h minus a. And when you reduce this, this a will be canceled with this a, right? Because you have a minus there. You have this a plus h minus a, and this a with this minus a will amount to 0. Can you see that? And basically what we're going to have is the h alone. Let's continue. The slope of the second line is equal to this binomial to the square. Let's raise this binomial to the square. Something that you should know by now, like second nature. And this is a squared, so I just write a squared. over h. Let's continue. We're just working this out. We're working with this expression over and over again and see if we can get something easy or simple or something like that. Okay, what else can I do in the numerator? I have a squared and I have a minus a squared. So when I put them together, they're gonna amount to 0. So I can just get rid of them. By the way, this is 2ah. It doesn't look very well. 2ah. Okay, so basically another simplification is this: 2ah plus h squared over h. Okay, and the next point or the next step is probably the most important in all of this deduction. Okay, this is where you have to be really, really, really focused. Okay, look at this, guys. Now, the next trick I'm gonna do is the following. I'm gonna divide this fraction, the numerator of this fraction and the denominator of this fraction by the same number. Okay, can I do that? Yes. If you have this function, this fraction 4 over 8, I can divide in both sides over the same number and I'm gonna get an equivalent fraction. For example, 4 over 2, I get 2. 8 over 2, I get 4. And this, obviously, is an equivalent fraction to this. So you can always divide both numerator and denominator by the same number as long as that number is not 0, right? Because we don't allow divisions over 0. So let's do it right here. I'm just going to express it first. 2ah plus h squared over h over, and this over is this one, over h over h. And I'm going to make the precise annotation or the precise requisite that h cannot be 0. H has to be different than 0 in order to perform this very important step. And like I said before, this is probably, I'm going to mark it with a star, one of the most important parts in this section. One of the most important, at least. Okay, now let's carry out such thing. Let's carry out the division. We're going to continue in here. Okay, so I'm going to divide all of this. You can do it on your own. I don't need to explain the division of a polynomial over a monomial. What you are going to get is 2a plus h. Okay, this is all of this division. I'm not going to do it for you. Over h over h. How much is this? It's 1, right? So we just write 1. And basically, we simplify a little more. 2a plus h over 1 is the same as 2a plus h. Okay, we're going to stop right here for a moment. Now what? What happens now? We have arrived at a very simple expression. Can you see? We started with this, all of this stuff, which looks complex and so on. And by doing algebra and some little tricks like the division over h, as long as h is different than 0, etc., we have arrived at this expression, guys. We have arrived at the expression that tells me that the slope of the second line, this second line, is equal to 2a plus h. That's it, right? Okay, now here comes the other very important point or very important step in this whole process. This is the real, the essence of this whole process. Okay, I'm gonna draw in, let's choose white. Remember, what are we trying to do? We're trying to find, in the end, our goal is to find the tangent. And I need to erase a little bit in here. Remember, this is point 1 and point 2, but I don't want to have those labels because the drawing is going to look very bad. In white, I'm going to draw the tangent line right over here. Right there. Okay. Okay. We need to find, this is what we're trying to get, the slope of the tangent line to this function at this point. Okay. But so far, what the only thing that we have gotten is the slope of the second line is equal to 2a plus h. Okay, Now, this is where it gets interesting. If you remember from the software that we were studying before, this one, the way in which we can help ourselves get the tangent of this red line is by approaching the second line towards the red line in this way. So basically, we're trying to approach the point 2 towards the point 1. So this is a process of limit, you see? We want to see what the limit is as P2 approaches P1. That's the whole idea. You see? Like so. Ever so more. Okay. So if I go back to my analysis. Okay. Remember, this is the point number 2 right here. This is the point number 1. And I want you to notice that as this point 2 gets closer and closer and closer to the point 1, I want you to imagine the red line moving like in the software. Imagine it, okay? Just imagine the whole diagram moving. And my question is this. When we do that, guys, what's going to happen to the increment h? What's going to happen to the increment h? Okay. Maybe I can draw it in here. Okay, this is 1 second. This is my tangent. And look, the increment is the distance from this point, the horizontal distance from this point to this point. Can you see? It's the horizontal distance from this point to this point. It's all of this little bit, all of this part in here. And as the point 2 gets closer to P1, that distance h, or that increment, will also approach get less. It will approach 0. Okay, for example, look at this. This is P2, this is P1. What if I move P2 towards this point, or so that it becomes this point now? You see, now the increment, which in the first case was from here to here, this was h, all of this was h. Now, since I moved P2 towards this point, now such h is reduced from this one original to this other one. You see, the h, the increment, is getting less. And as you approach P2 towards P1 more and more and more and more, this h will approach 0 more and more and more. It will never be 0. Why not? Because of this. You see, we are not allowed to say that h is 0, but we can approach it to 0 no matter how much, okay? But never quite there. Okay, that is why this is important, and that is why the process of limit is important, because if you remember, in limits you can get as close as you want but not be there exactly. That's why the concept of limit is important, guys. So let me wrap it up very quickly because I don't want this to be any longer. Okay, so basically, what is our conclusion? Our conclusion is this: that the slope of the tangent line is equal to the slope of the second line as long as, or when, P2 approaches P1. Okay, I'm going to repeat this phrase. The slope of the tangent line will be equal to the slope of the second when P2, which is this point, approaches P1. Another way to say the same thing, an equivalent thing, is the slope of the tangent line is equal to the slope of the second line when h, the increment, remember this increment, approaches 0. You see, this statement and this statement are equivalent, are completely equivalent. And now with this conclusion, guys, now we can get the slope of this y tangent at this point a comma f of a. Why? Because I look back at my slope for the second line, which is this. Okay, I look at this. Sorry, I look at this. I bring it over here, and I go this and I do the following. Okay, what's gonna happen to this expression when h approaches 0? Okay, what's gonna happen is that this will become 2a, all of this, because h will approach 0. So 2a, I'm sorry. So all of this expression will become 2a. In other words, we can write the following: the slope of the tangent line is equal to the limit as h approaches 0 of the slope of the second line. Or in other words, the slope of the tangent line is equal to the limit as h approaches 0 of ms. What is ms? Solve of this, 2a plus h. Or in other words, the slope of the tangent line is equal to 2a. Because when I evaluate this limit, the limit of 2a plus h in this number as h approaches 0, the result will be just 2a, right? Because we can evaluate simply, we don't get any zeros in any denominator, and so the slope of the tangent line is equal to 2a. And we have solved our problem. The problem that we started with, if you remember, was finding the slope of the tangent line at this function x squared at the point 1, 1. Why do I say that this is the solution, guys? Because now all you have to do now is replace your a by 1. You see? That's all we have to do. This is a general formula for getting the slope of the tangent to this particular function in any number a of x. Okay, when you replace this a with any value of x, you will get that tangent. So for our particular point, which is 1, 1, I don't have any other space over here. uh, let's put it over here. This is my original point. Okay, all I need to do is replace this number, the x number, the independent variable, in here, and I'm done. So basically, I'm gonna conclude over here. Basically, the slope of the tangent line at point 1, 1 is 2 times 1, which is 2. So this is gonna be the answer, guys. Let's wrap it up. The slope of the tangent line at point 1, 1 is 2 for this specific function of x squared. It's gonna be 2. So basically, if we go back here, okay, remember this is our tangent line. The slope of this tangent at this particular point, 1, 1, will be the number 2. The slope of this tangent is 2, and we have solved the problem. That's it. Now, if remember the other problem, calculating the same slope at the point 3, 9. I think it was 3, 9 or 2, 4. I can't remember. Let's suppose it was 3, 9. All I have to do is now replace in my formula, which is this. I only need to replace the number 3 for the a, and that's it. So it's gonna be 2 times 3, 6. So the slope of the tangent line to this function at point 3, 9 will be 6, and that's it, right? So basically, we have solved the general problem. This little formula here gives you the tangent, the slope of the tangent to this function at any point you want. It doesn't matter. It's a general analytical solution. That's why we did all of these things, because without this, we wouldn't have been able to solve the specific problem, which was this, getting the slope of the tangent at point 1, comma 1. Okay, so I'm gonna finish right here, guys. This is my first time explaining this concept. It's a difficult concept. It's a very, very difficult concept. Believe me, in college for engineering and sciences and economics, in the first year of college, this gives a lot of headaches to students, and I'm talking about college students. So this is my first time doing this. I don't know if it worked out well. I wanna take feedback from you. If I failed in some way to really convey the message of what I did here, make me know. Make me know, please, because this is my first time explaining such a tricky and subtle concept. This is hard to understand. And if you think that I did not do it very well, or you think I need to explain it again in a much, much better way, let me think about it, and I mean let me know about it, and that's it, okay? But I need you to watch this video 2, 3, probably even 4 times, okay? It's difficult. It is difficult to understand these things. Do not believe anybody that says that it's not. It is difficult, and it takes time. Okay, let me stop right there.